In this video, we're going to look at the product, quotient, and chain rule of derivative. Let's go into the details of the video. Okay, so let's look at this typical example I have here and solve it together. So I'm given this function y equals, we have in bracket s cubed, okay, plus 2x, okay, bracket close, bracket open. We have x square minus 4x. Alright, and we're asked to find dy over dx or y prime. So, like I explained in my first version of this video, that's where I explained the basis of differentiation. I said there's another term for dy over dx is y prime. So that you say dy over dx or you say y prime or first derivative, the three terms mean the same thing. Okay, having done that, solution, let's solve this problem. It's very simple, guys. I'm going to show you. Now for product 2, it's important that you guys take notes of this formula. It's very important to help you in the long run. That's the formula for it. So commit it into memory and you'll be good to go. So the formula says for product 2, we have it to be u dv over dx plus v du over dx. So this is the formula for product 2, guys. So I'm going to break it down so that you understand it. Now, the first thing you have to do is to label each of these brackets. So you can label this first bracket here to be your u, then label this second one to be your v. So guys, having done this, u dv over dx, what it means is that you should leave the values for u and differentiate the values for v, then plus this time around you leave the values for v and then differentiate the values for u. Okay, having known that, so what it means here now to now be equal to, so in bracket x cube plus 2x bracket close. So this time around differentiate the values for v. So when differentiate what is in this bracket for v, when differentiate x squared, we're going to have 2x, okay, minus 4. That's what we're going to have, guys. Then plus this time around leave v in brackets x squared, these are v minus 4x, then differentiate u du over dx. That's what it means. So when differentiate the values in u, we're going to have 3x squared plus 2. So for those of you that might be confused on how I got 3x squared plus 2, or how I got this 2x minus 4, in my first video I explained this. That's a principle, general principle of differentiation, which is to reduce the power of x by minus 1. If you are still confused, I recommend you check my video on the basis of differentiation and watch it before proceeding with this one, that you'll not be confused, so that you understand the basics and flow effectively in this product rule. So guys, having known that, let's go ahead and finish solving this problem. Okay, so let's expand, guys. So to expand this expression we have here, this bracket will multiply this bracket. So let's do it together, guys. Very, very simple. So let's begin with, it's going to be x cubed multiply 2x minus 4 bracket close, okay, plus 2x multiply what we have here, 2x minus 4, okay, plus this time around s square multiply 3x square plus 2 bracket close, okay, minus 4x multiply 3x square plus 2. Okay, so equal to, let's keep expanding, guys. So let's simplify this. S cubed times 2x, we're going to have 2x raised to the power 4. Okay, s cubed minus 4, we're going to have minus 4s cubed. Okay, plus 2x times 2x, we're going to have 4x squared. Okay, 2x times minus 4, guys, we're going to have minus 8x. Okay, so plus we have x squared times 3 s squared, we're going to have 3s raised to the power 4. Okay, plus s squared times 2, we're going to have 2s squared. Yeah, correct. So we have minus 4x times 3s squared, we're going to have minus 12s cubed, right? Yeah, correct, guys. Now minus 4x times plus 2 or times 2, we're going to have minus 8x. So guys, having done this, let's collect like times. You see, collect like times. Very, very interesting, guys. So to collect like times, let's bring the terms that are similar. So let's begin with the term that has the highest power, which is 4 in this derivative. So we have 2x raised to the power 4, okay, plus 3x raised to the power 4. Okay, now let's continue with the one that has 3. Let's say minus 4x raised to the power 3. Okay, we have minus 12x raised to the power 3. Right, then let's go to 2 plus we have 4x raised to the power 2. Okay, we have plus 2x raised to the power 2. Right, are we missing anything, guys? No, we are getting it. So let's go to the least power, minus 8x, and lastly minus 8x. Okay, we're almost done, guys. So our final answer, dy over dx will be, so 2x raised to the power 4 plus 3x raised to the power 4, so we have it to be 5x raised to the power 4. Okay, minus 4x cubed minus 12x cubed, we're going to have it to be minus 16x cubed. Okay, plus 4s squared plus 2s squared, we're going to have it to be 6x squared minus 8s minus 8s, we're going to have it minus 16x. So that would be our final answer for this derivative. It's as simple as that, guys. Given this function, y equals, we have x raised to the power 4, okay, minus 2x all over, right, we have 5x raised to the power 3, okay, plus 4. We have to find dy over dx. Okay, so another term for dy over dx is what? Y prime. So you see that you say dy over dx, or you say y prime, they both mean the same thing order. Okay, so let's go straight to the solution. Now, just like product 2 has a formula, question 2 also has this word formula, and it's important you guys commit it into memory. It will help in the long run, because without it, you will be able to solve problems involving question 2. Any differentiation of derivative that is fraction, that has fraction, is question 2 that you apply to solve it. So the formula for question 2, quickly, we have it to be v du over dx minus u dv over dx all over what? V square. Okay, so our u is usually our numerator value, our v is usually our denominator value. So we can bring them out. We have u equals to x raised to the power 4 minus 2x. Okay, we have v equals 5x raised to the power 3 plus 4. Okay guys, so let's go ahead and solve this problem. So v du by dx means we should leave v and differentiate u. So look at what it means, guys. So it's going to be 5x raised to the power 3 plus 4. So differentiate u. When you differentiate u, you are going to have 4x cubed, okay, minus, when differentiate 2x, we're going to have 2. That's 4x cubed minus 2, okay, close the brackets. Then minus, that this minus here, minus, this time I want to leave u, or u here is, we have it to be x raised to the power 4 minus 2x. Okay, so this time I differentiate v. So when you differentiate v, you're going to have 15x squared, okay, plus 0. But when you differentiate a constant, you have 0. So having done these, guys, well, let's put everything here in brackets. Let's put everything in bracket, guys. So because they're multiplying each other, so let's expand. This is where, okay, over, before you expand the numerator, remember you have over v squared. So our v here is 5x raised to the power 3 plus 4, okay, square. Okay, so let's expand the numerator values. So the numerator values, we have it to be 5x raised to the power 3 multiply 4x raised to the power 3 minus 2, okay, then plus 4 multiply 4x cubed minus 2, okay, minus, this time around we have minus x raised to the power 4, okay, multiply 15x raised to the power 2. The 0 is nothing, so leave it. Then minus times minus, we have plus 2x multiply 15x squared. Okay guys, so let's simplify the numerator. So when you simplify, you have equal to 5x cubed times 4x cubed, guys. So we're going to give us 20x raised to the power 6, the law of indices. So we have minus 5x cubed times minus 2, that's minus 10. Right, we're getting it 10x raised to the power 3, okay, plus this is around 4 times 4x cubed, we're going to have 16x cubed, okay, 4 times minus 2, we have minus 8, okay, so this time around we have minus x raised to the power 4 times 15x squared, so we are going to have minus 15x raised to the power 6, law of indices, you add the powers. Okay guys, so we have plus 2x times 15x raised to power 2, that's 15x squared. We're going to have plus 30x cubed. Alright, so let's collect like times. So I can write here collect like times. Okay guys, so when you got like times, you're going to have 20x raised to the power 6. Which other term has power 6, we have 15, so minus 15 x raised to power 6. Okay, then which other one again? So we have minus 10 x raised to power 3. Okay, raised to power 3. Which other power? Okay, plus they are together 16x raised to power 3. Okay, which one has 3 as power again? Okay, we have plus 30 x raised to power 3. Okay, which other one? Okay, we have minus 8. That's alright. Yeah, not missing any other value. Okay, so let's simplify the more. 20x raised to power 6 minus 15x raised to power 6. We're going to have 5x raised to power 6. Okay, then we have minus 10x cubed plus 16x cubed plus 30x cubed. Okay guys, so let's do it this way. Let's apply bottom as a little addition before subtraction. Wait, 16, so we're going to have 16x cubed plus 30x cubed. When you do addition, so we're going to have 46x cubed, then minus 10x cubed plus 46x cubed, you're going to have plus 36x cubed, okay, minus 8. Okay, so finally, therefore, dy over dx will be, so we bring everything together, we're going to have 5x raised to power 6 plus 36 s cubed minus 8 all over v square. V square is what? We have it to be in bracket 5x raised to power 3 plus 4 square. So this will be our final answer. So guys, that's it for question 2. Is as simple as that. It's giving the function y equals in bracket 4x cubed, okay, plus 2 bracket close raised to power 5. Okay, so solution. Now note that another term for chain rule is function of function. Either you say chain rule, you say function of function, they both mean the same thing, so don't be confused. Okay, so for this particular question, the y prime or dy over dx of it, as usual. Another term for y prime is dy over dx will be, now this is the idea behind it. First of all, this power, we subtract 1 from it. As usual, the rule of differentiation, you reduce the function by 1. So you subtract 1 from this one. At the same time, this power come and multiply these values in the bracket. So it's going to be 5 in brackets 4x cubed plus 2 bracket close. So 5 minus 1 give you 4. Now, once you have done this, next thing you're going to do will be to find the derivative of the value in this bracket. So once you find the derivative of the value in this bracket, you use it and multiply this 5 here. So the derivative of the value in this bracket will be, so you're going to have 5 multiplied, so the derivative of 4x cubed will give you 12x squared. Okay, the constant there is 0, is nothing, so bracket close. Okay, raised to power 4. So now your final answer will be, so 5 times the derivative of what is needed, but that's 12x squared. We're going to have 5 times 12x, so we're going to have 60x squared. So your final answer in brackets, bring back the original value in the brackets, which is 4x cubed plus 2 raised to power 4. So this is the derivative of the function dy over dx is equal to 0. So that's the pattern or idea behind chain rule of function of function. This is how you solve it. Now let's look at another example and solve it together before we run it off here. Okay, so another example I have here. So we're given this function y equals in bracket 4x minus 3 raised to power 5, and we're asked to find the 2y over dx cube. Okay, so feel free to pause this video and see if you can find the first derivative before you solve it together. Okay, so let's do it together. Now, let's find the first derivative. That's y prime will be, okay, as usual, subtract 1 from this 5 and ascend this 5 multiply this bracket. So we're going to have 5 in bracket 4x minus 3. So 5 minus 1, we have 4 here as the power. Okay, so find the derivative of the value in the bracket. So it's going to be 5 multiplied derivative in the bracket, which is going to be 4. The derivative of 4x is 4. The constant there is 0, so it's nothing. So bracket close, raised to power 4. So the final value for the first derivative will be 5 times 4 is 20. Okay, that's 20. Bring back the values of the brackets, the original values of the brackets. That's 4x minus 3 raised to power 4. So this is the value for the first derivative. I hope you got it. Okay, now finally the second derivative is y double prime or the 2y over dx cube will be, so differentiate once more as usual. So this power subtracts, this my 1, subtract 1 from this 4. At the same time, this 4 will come and multiply this 20. So you have 4 times 20 in brackets. So we have 4x minus 3 bracket close. So let's subtract 1 from this 5. We're going to have 3 as the power here now. So let's break it down. So we're going to have 4 times 20, 80. So 80 times the derivative of what is in this bracket. So we're going to have 4. The derivative of 4x is 4. The minus 3, the constant is 0. So it's nothing, it's the power 3. So our final answer will be 80 times 4 will give us 320. So bring back the value of the original value of the bracket. So we have it to be 4x minus 3 bracket close raised to power 3. So this is the final answer, the second derivative, 320 in bracket 4x minus 3 bracket close raised to power 3. So that's it for this class, guys. I hope you learned something very interesting.